Lesson 2.9 covers methods of the math class. The math class is another class that's included within the java.lang package. In addition to string, integer, double, math is another one that's included by default. The math class houses a bunch of static methods that function in the same way as like a typical scientific calculator. If you wanted to take a square root or an absolute value or any other type of exponent, perhaps, this is a place where you could find methods for that. Okay, you could look at the class's API online and see all of the methods available from the math class. There's only a few that we need to learn about. I'll cover all of them today. Now, I mentioned that the methods are static. And so one of the things we're going to look at today is how to call a static method. Static methods are called using the dot operator along with the class name. It's a little bit different. That's not the object name. So you don't need to create an object from the class to call the method. You can actually call the method through the name of the class. Let's take a look at what this means. I've included another class here called method examples. And it's like a typical class. I've got a constructor, okay? And I've got a couple of methods. One of the methods I've made static is called method 2. The other method you'll notice I didn't make static. I did not include the word static for method 1. So if it's a static method, you can call it through the class name. And that's what I'm doing here. The name of the class is method examples. Now, notice what I did not do, okay? I did not make an object from the class through the class's constructor, okay? Previously, anytime I wanted to call a method from a separate class, I had to first create an object from it. Well, again, I didn't take that step today, and I'm able to still run this code, and I shouldn't get any type of compile error because I'm calling a static method, and you're allowed to call static methods this way. Now notice it says unless they are defined in the enclosing class. So you may notice I called method 3 here. There was no method 3 within method examples. I actually declared method 3 down here. So this brace closed my main method. I'm still within the class called main, but I've stepped outside of the main method and I've opened my own new method, okay? And I made it static. Since I made that method static and I'm within the class that it is, I can call it without any type of reference. And we've seen that previously with methods. When you're in the same class as that method, okay, you can call it without any type of reference. Now, if I did want to reference this method, I would reference it through the name of its class. Now, this method, it's not in method examples. It's in the class main. So technically, I could reference it through the name of the class because it is static. I don't need to do that. In fact, it'd probably be discouraged. Okay, but you could. And technically, I could create objects and call these methods that way. But again, it's not really the encouraged way to do it. So I could make an object called test. I could call method through test, but it wouldn't be the preferred way. Call static methods through their class names. Now, if I tried to call method 1 using either of these two ideas, ways that I'm calling these other methods, I'd get an error message. So method 1 is not static. So I cannot call method 1 through the name of its class. Method 1 is not declared within the main class. So I couldn't call it locally either. Okay, and it's telling me that right here. Non-static method 1 can't be referenced this way. If I wanted to call method 1, I'd have to go back to the old way of doing it, like we saw earlier. I'd have to make an object and then call the method through the object's name. Okay? Well, in the math class, there's several methods that are of interest to us. You could read about more of them on your own time, but the only ones that we're required to learn are these. There's an absolute value method. And the absolute value method, it's called abs. It returns as an integer if you give it an integer. It's kind of an interesting method. It's got an interesting overload. If you give it a double, it actually returns a double. So if you give it an int, it gives you back an int. If you give it a double, it gives you back a double. So it doesn't change the type. And just like you would expect absolute value to do, it simply returns the positive value. Okay? So if I gave the absolute value -9, it would give me back positive. And if I gave it back -9.87, it would give me back positive 9.87. So if you gave it a positive number, it would give you back the same number. Okay, it's not going to like turn a positive negative. Right? So typical absolute value. Now there's a Pow method. Okay, this is like your exponent. Okay, so POW, Pow, you have to give this method two arguments. Let me set that. Okay, so the two arguments that you give it have to be the base and the exponent. All right, and so the base would be, like if I'm doing 3 to the 5th power, the base would be 3. The exponent would be 5. It returns the value of the first parameter raised to the power of the second parameter. All right, so right here, I did 3 to the 4th power. You might know that that's 81. Now, something a little peculiar happens. Even though 3 and 4 are both integers, and 3 to the 4th power is 81, you might notice that it returned 81.0. So the return type of this method is simply double. This is not like what we saw up here with abs. Abs has an overload. If you give it an int, the return type's int. If you give it a double, the return type's double. In the double Pow method, okay, doesn't matter if you give it int or doubles, it's actually going to give you back a double every single time. So it's always going to widen it. It's always going to make it a double, even if it doesn't need to. And remember, you can always give ints when doubles are expected. It's the reverse that you can't do. So if it was expecting me to give it ints and I gave it doubles, then I'd get into trouble. But this is actually okay. And it can handle weird things like I don't even know what this one was, but you can see it over here. It's this number 0.02 something. Okay. So I wouldn't put something like that on a test because you don't get a calculator, but okay, it can handle all kinds of weird things. All right, there's a square root method, sqrt. Okay, you give it a double, and it gives you back the square root of that double. Now again, since the method's return type is double, it's gonna make it a double, even if it doesn't really seem to us like it needs to. Like the square root of 25, we would probably just think it's 5, but you'll notice that it actually printed 5.0. Okay, so it's always going to return as a double. Even if you give it an int and the square root could be expressed as an int, it's still going to force it into a double. Here it gave me 2.5. And notice these are return methods. So if you notice what these method calls I'm making, I'm using them within expressions. Their return, you could use their return to initialize a variable as long as it was the appropriate type, then it should be fine. Like if I tried to, one thing I've seen students kind of get in trouble with is if you tried to put that directly into an int, you would get an error message. Even though we look at it and we go, well, what does it matter? It's just 5. Since the return type's double, if I tried to initialize an int with it, I would get an error message. I'd have to cast it to be an int. This is a square root. Now, so what if we needed like a cube root or, something to the 2/5 power? Well, you could always use the Pow method, right? So if you wanted, say, a cube root, that's the same as a 1/3 power. And so you could put that 1/3 in as the exponent. Just be careful. If you put 1/3 like that, like integers, it would become 0 because it would still do integer division, right? If you weren't careful. So make sure you put like 1.0 divided by 3 or something equivalent to that. Now, the trickiest method probably that we'll see from the math class is random. And this method, you'll probably see on your AP test 2 multiple choice questions based on this, and it might even be part of a free response question. This is one of those things that like the College Board likes to use to kind of, I don't know, separate the A's from the A pluses or whatever, the 5s from the 4s. So this is a method that they're going to emphasize. They want to see that you can manipulate this random value that's produced as a double between 0 and 1, inclusive of 0, exclusive of 1. Can you maybe manipulate that into like other things? Like, so for example, let's say you're playing a game where there's a spinner and it's going to spin a 1, 2, 3, 4, or 5. Well, could you use this random method that gives back a double between 0 and 1 to randomly produce integers 1, 2, 3, 4, or 5? There's ways to do it. You're going to have to cast from double to int. You're going to have to multiply to kind of spread out the range. You're going to have to maybe add or subtract to the values. So there's various things that we'll do, and we'll try a couple. Okay, but just understand when you run math.random, it's always going to give you a double. That double could potentially be zero, but the odds of that are, we're talking like 1 divided by 2 to the, I think, like 63rd power or something crazy. I mean, it's astronomically small, okay? But it could technically happen, but it will never produce 1. So the biggest number it could make is like 0.999 with, I think, 15 nines or maybe 16 nines. Okay, so it's like it's between 0 and 1, but it could, in theory, make a 0, but it will never make a 1. So we say it's inclusive of the 0, exclusive of the 1. That's its defined range, okay? Now, like I said, sometimes we're going to try to manipulate that range a little bit. So let's say I wanted to make random int values from 1 to 100 inclusive. So inclusive, if you're unfamiliar, that means that we want to include, right? Think inclusive, include. We want to include the 1 and the 100 as possibilities. If I said exclusive, then we would exclude. We wouldn't include the 1 and the 100. So technically, we'd be going from 2 to 99. Okay, but if I want to go from 1 to 100 inclusive, that's like I have 100 different possibilities. Okay, now if you took math.random, now remember what I was just saying about math.random. Math.random goes from 0.0 to 0.999, a whole bunch of nines. Okay, if let's say you multiplied that, okay, whatever that number is, let's say we multiplied it by 100. Think about like what your typical multiplication properties tell you about that. Okay, 0 times 100 would still be 0. So in theory, we might still get 0. But what happens if you multiply 0.999 times 100? You would get 99.999, however many nines there are going to be. Now, I'm trying to make int values from 1 to 100. I'm getting closer. I'm getting closer. Okay. If I took those numbers and I cast to int, think about what you learned about type and casting here. Okay. You truncate. So technically, if I did a cast, these numbers would now become 0 on the low end. But my high end wouldn't be 100. It would be 99. I'd have, no matter how many 0.9s there were, truncate means I'm going to throw it away. And it's just going to be 99. Now, remember what my goal was. My goal was to get this from 1 to 100. Now, if I did an add 1 to all of this quantity, then my lowest possible number would be 1. Hashes over here. And my highest possible number would then be 100. Okay? And so if you look at my formula here, that's what I did. Now, the only thing I could really change here, technically it didn't really matter when I added that plus 1. Okay? It does matter when you multiply though. So it's crucial. If I don't put these parentheses here, and let's say that I just wrote the same thing without the parentheses, you could run this as many times as you wanted. You would never get a number like here I got 68, which was just a random number from 1 to 100. The number that F would produce now would not actually be random. I can predict it. Okay, you could run this as many times as you want. I promise you, you would get the number 1 every single time. So I'll prove it to you right now. I don't know what's going to happen, right? It's random. But watch, I'm going to get the number 1 where 68 used to be. So how did I know it was going to make the number 1? Well, the way that I knew that was because I messed it up. Okay, when I took those parentheses away, all of a sudden the cast took over the precedence from the multiplication operator. Why is that so crucial? Well, what's going to happen if you were to cast this number here before you multiplied it by 100? Think about it. If you don't multiply by 100 first and stretch it out from 0 to 99, and you do a cast, what's going to happen to 0.999 when you cast it? It's going to become 0. And so now your range of potential values is just 0 to 0. And so when you multiply by 100, you're still going to be 0 to 0. If you don't multiply first and cast second, the whole thing gets destroyed, okay? So I need to put these parentheses here around the multiplication step, force it to multiply before I turn it into an integer. The +1 doesn't actually matter. So you could add the 1 prior to the typecast or after, because that's just kind of shifting at 1 unit. It's not actually like spreading out the range of possibilities. But the multiplication step must happen prior to the cast, okay, when you're doing some sort of situation like this. And there's some more examples in CS Awesome, and I'm going to give you some more examples to try later in class. Here's another one. This time I wanted random double values. So I wasn't asking for random int values, just random doubles from 3.5 to 7.5. And notice that I've included 3.5 as a possibility, but I've excluded 7.5. That makes it a little bit easier for me because the random function is kind of set up this way naturally, right? It's going to include the value on the left and it's going to exclude the value on the right. There's ways we could come around this and make it maybe include the one on the right, but not the one on the left, or include both. But it's a little bit tricky. It's probably not worth worrying about too much. Let's just say we wanted to get this range, okay? And I don't think I'll ever make it much more complicated than this on a double. Well, in the last problem, I noticed how from 1 to 100 was like 100 values. From 3.5 to 7.5 is a range of 4 values. So I multiplied by 4. And since this could technically still produce 0, where I wanted the minimum value to be produced to be 3.5, the last adjustment I made was to add 3.5. And then that sort of shifts my range. Instead of going from 0 to 4, now I go from 3.5 to 7.5. And then I didn't bother putting a cast here because if I put a cast, I would have random ints and I wanted random doubles and I wanted to include everybody. I didn't want to kick out the ones that weren't integers. And so now every time you run it, like this time I got 6.95. Every time I run it, I don't know what I'm going to get, but I'm going to get some number from 3.5 to 7.5. In theory, I might see 3.5, but I'll never see 7.5. Okay. I really encourage you to look at the CS Awesome problems here, and you may even have to go a little further into your studies. Maybe you have to go onto the internet and find some other examples of how math.random can be used. And I'll give you some more problems to try in class as well. But that one's definitely a little trickier than the other methods.